So far, we've used the angle sum and difference formulas for the sine in one direction across these equalities, right? We worked a problem where we evaluated the sine of 15 by thinking about the sine of 45 minus 30. And so we went to the right side of the formula and used the familiar angles of 45 and 30 to evaluate that problem. In this video, let's go in the other direction. Right? So we're going to start with something that looks like the right-hand side, convert it to a single sine of some angle, and hopefully that angle is something that we know something about. Okay? All right, so number one, sine of 125 times the cosine of 25 plus cosine of 125 times the sine of 25 degrees, right? So on this right side, we have exactly the right side of our angle sum formula, where the u is just 125 degrees, and the v is 25 degrees, right? We have sine u, cosine v, cosine u, sine v, right? With addition in the middle, so I can use this formula going the other way across the equality to say that this is the sine of 125 plus 25. And adding 125 and 25, I get 150 degrees, which is one of the special angles on the unit circle. I know that this value is 1/2. Right? So in this problem, we started with something of the form on the right side and went over to the left to evaluate the expression. Number two, sine of 5 pi over 12 cosine pi over 12 minus cosine 5 pi over 12 sine pi over 12. So if 5 pi over 12 is my u, it shows up here and here. If pi over 12 is the v, it shows up there and there. So I have sine u cosine v minus cosine u sine v. That's exactly the difference formula for the sine, right? So this is the sine of 5 pi over 12 minus pi over 12. That argument simplifies to 4 pi over 12. And I can simplify that further to pi over 3, which is another angle, another of the special angles on the unit circle. The sine of pi over 3 is radical 3 over 2.